Welcome, everybody, to today's webcast. We are joined by Tanya Janca, who is going to be doing a presentation with us on 30 tips for secure JavaScript. And if you don't know, JavaScript is the best programming language that exists. Prove us wrong. Just kidding. Anyway, Tanya, I'm going to go ahead and jump to the backstage. I will let you get started. We'll be coming back when there's about 10 minutes left to go over questions and all that. But enjoy. Have a fun time.
Thank you so much, Zach. Thank you, everyone. Um, Thank you so much for coming. I'm Tanya, and I want to talk to you about JavaScript today. And there are many, many programming languages, and I'm not going to say this one's the best, but it's certainly the most popular one by a lot. Like, it is the most popular web programming language because it is the front end of the internet. Like it's what makes websites beautiful and reactive and and so much nicer looking than when we did Windows forms and before that when we did text-based screens. And I don't know how old you are when you're phoning in, but there are all sorts of different programming languages that don't even have user interfaces. And so JavaScript makes things absolutely stunningly beautiful. And that's why it's so magical. And that's why it is all over the world all the time. And so let me be more clear. What are we going to talk about today? We're going to talk about writing, sorry, we're going to talk about writing better JavaScript. And so to me, if you write super amazing JavaScript, but it is insecure, it's not the best JavaScript. It can't be spectacular and amazing and wonderful if, you know, a malicious actor can get into your app and steal your user's data, right? So we want to talk about writing superbly fantastic JavaScript. And we're going to talk about also what to do and what not to do. So I said 30 tips for secure JavaScript, but there's more than 30 tips. So I'm already a liar, it's true, but 36 or 37 tips for secure JavaScript doesn't like roll off the tongue the same way. And so we do what we can with titles. So there's more than 30. We're also going to talk about a bunch of free tools to help you write more secure JavaScript because not all of us work at a big company that has lots of cool AppSec tools that can secure all the things for us and check all the things for us. Not all of us have an application security team or even one AppSec expert at work that can make sure that our apps are secure. Not all of us can have a pen tester come and punch our app in the face a whole bunch of times, but with love, so to make sure that it's safe, right? And so sometimes it's all on us. And so I wanted to give you a list of free tools that can specifically help check JavaScript. And so obviously we need a quick meme because how we describe the cyber attackers, but our actual attackers, I can be a little silly, and so this is sort of a warning that I can be a little silly. But I really love code and I really love secure code. So let's actually, I guess first let's do the about me. So who am I? So I'm Tanya Janca. This is the mandatory about me slide where we try to convince you that we are competent to give our own talk and that we're worth sitting a few more minutes and listening to. So I work at SemGrep. I am also known as She Hacks Purple because I couldn't choose between red teaming and blue teaming. I kept doing pen testing, but then I also kept helping developers fix bugs. And when you can't make up your mind, you get called purple. I wrote some books, the Alice and Bob Learn series. I've worked in tech. I actually need to update this. It's now 29 years. This is my year 29, so I am maybe a little older than I look. I founded some things, so I started a whole bunch of different things that in efforts to try to help people. I'm an advisor at Catalyst. Oh, and Smithy now. I just signed last night with Smithy. And I'm a faculty member at IONS Research, which is an American company that does like a whole bunch of different things, and I am one of their faculty members. So when you can phone a friend or phone a nerd, which is what they call it ask an expert, but I like phone a nerd. Anyway, I'm one of the nerds. But hopefully all of this, you're like, she seems tolerable. I will listen to her discuss JavaScript. We'll see how this goes. Okay, let's go. So I want to talk about JavaScript. JavaScript is the front end, the visual GUI, the graphical user interface. It is all of that of the internet, the whole internet. Someone might write something in TypeScript, but it just gets transpiled, not not compiled, transpiled into JavaScript. That's what happens. And TypeScript is awesome, but we're not going to talk about that today. But what you need to know about JavaScript is that it's beautiful, it's amazingly interactive. It's what makes the internet something that calls back to you, something that you go back and forth with, and it you make requests, it gives responses, as opposed to like long ago where we just had static web pages. JavaScript makes an app respond to you. But the other thing about JavaScript is that across the internet, a lot of it is riddled with vulnerabilities, especially cross-site scripting. Cross-site scripting is the only vulnerability that just affects JavaScript. It's a type of injection. So basically us tricking, like a malicious actor, tricking an app into thinking, oh, this data that the user sent me, that's code. I know what I should do. I should interpret and run that code. That's what I should do. So that's what happens when JavaScript gets attacked by cross-site scripting successfully. A malicious actor sends it something that should be treated as data, but the app gets confused and it decides to execute that JavaScript instead. And bad things happen. And so I don't want that to happen to you. And so I want us today to learn to write more secure JavaScript. Um, so in case you missed the memo, which you probably haven't or you wouldn't be here, so please forgive me. This is in case this is their first cybersecurity event they've ever been to. But secure code matters now. It matters for a business's bottom line. So when I started doing AppSec, it was like, we should probably do this. It wasn't legally mandated. Lots of like there were very few attackers back then. There weren't like we weren't in the common news all the time. Like I'll have my mom call me and say, "Did you hear about that hack?" My mom, she's retired and she hears about stuff going wrong in our industry. And so customers care about security. They care about the reputation of your organization. Like your organization can go out of business if there's a major cyber attack or a data breach. And plausible deniability is completely not acceptable anymore as an excuse. There is a statistic in Canada from 2022 that if a small business is hit by a successful cyber attack, 50% of them just go out of business. They just can't make it back. And most Canadians work at small businesses. More than 50% of us do. Like 50% of businesses in Canada are small businesses, or sorry, 50% of people work at small businesses. There's way more small businesses than medium and big. And like to imagine that half of them could just go out of business like that, it's really quite terrifying. So we, as people that build and people that protect, we need to build and maintain user trust. We need to maintain compliance standards. We need to obey legislation. We need to protect our users' data and their rights and their privacy. We want to avoid business disruptions. And we do all of this by building safe software. And so that's what we're going to talk about today, how we secure our JavaScript. And so I'm going to go point by point by point. And let's go with number one. So the very first one is use a framework that outputs and code for you. So there are lots of JavaScript frameworks and all the nice new ones like React, Angular, Vue.js, like the cool kids ones, all of them are what they'll do is they will output and code most things for you, almost everything. You want to be careful because there's some dangerous functions inside of these frameworks. So for instance, React has one called dangerously set inner HTML. So if you're going to use that, you're saying, don't output encode it. I've got this. And you need to be very careful when you use that. Or for instance, if you're using Angular and you use bypass security trust as, that's a function, and you're saying, turn off the security feature, you can trust me. You need to be very, very careful if you're going to use functions like that. So when you use a new framework, which are awesome, by the way, they're very secure. They have so many cool features that help with security and with making things beautiful and amazing and easy to do. But make sure that you check out the functions that you should avoid. And I'm going to give you a quick list of 6 things, but I'm not going to dive into each of these frameworks today. However, in the future, hopefully Black Hills and I will do like a full training where we'll code in all sorts of things. But for today, definitely use a framework that will output and code for you because doing it yourself is extra work. So number 2, we want to follow a secure system development lifecycle. And so if you are developing software, hopefully you are doing an SDLC. So that's where, if you're doing waterfall, you would gather requirements, then you would do design, and then you would do coding, then testing, then release and maintenance. If you are doing agile, you would do many different little circles of that where you are constantly getting feedback. So you're building what they actually want instead of what you think they want. Like with waterfall, if you're doing DevOps, you're doing the beautiful eternity symbol where you are constantly improving the software you have built. And it is more likely with newer system development life cycles that you're going to build better software. But if you want to do a secure system development life cycle, which is for every language, not just JavaScript, I know, you add threat modeling when you're doing your design. You add security requirements when you're gathering requirements. You do software testing like static analysis, software composition analysis, dynamic scanning. Like there's many different, like you scan for secrets in your code. There's many automated tools that can help with this. You review your design for security issues. You attend things like this so you know which functions not to use and which functions you should use. And they're recording this. So after you can review and take more notes if you miss something. And there's going to be a bunch of free resources at the end where you can keep learning. Like you keep attending these webcasts, you're going to know a lot. Okay, so number 3, take cross-site scripting seriously. So XSS is sort of the short form for cross-site scripting, which is a vulnerability that has been on the OWASP top 10 risks to web apps for 20 years. It is a seriously huge problem where essentially your your app is tricked by a malicious actor and they find a place where there should be data and they put in some code and somehow they trick your app into executing that code. And it executes in the browser right against the user. And you may be thinking, well, why would a user attack themselves? That seems really dumb. Yeah, usually what happens is someone clicks a phishing link or they go to a site that they shouldn't. And then there is a script inside of that that pops up and attacks them. Or if they're really unfortunate, they go to a site that someone else has already attacked and it had stored cross-site scripting. So it's actually hiding in the database. And then a completely innocent user goes and uses this site, they search for vacuum cleaners, and then that is the record that's been attacked that has the stored cross-site scripting. It comes out and attacks them. We need to take it seriously by performing the following things. So we do input validation. And input validation means checking that what we have accepted into our code is what we're expecting. And then on top of that, we would sanitize out any special characters that we must accept or we would escape. So I usually include that in my input validation lesson. Then we do output encoding, like we did in number 1, right? So we have a framework that outputs encode for us. That's perfect. Or we write it ourselves if we have to. So if you're writing something like PHP, it doesn't have a native function that does that for you. So you've got to write it all yourself. But lots of cross-site scripting frameworks have lots of beautiful output encoding functions for you that work gorgeously. And so we want to use those. And then on top of that, we use the content security policy header. So CSP for short, content security policy header, you list which styles you want to use. You list which scripts are okay. You list which media are okay. You list all the third-party things that you're using so that if someone successfully attacks against cross-site scripting, They can't get anywhere. They're so frustrated. On top of this, I would set the HTTP only flag on your cookie, but that's not JavaScript, so I didn't mention it. But I feel like security headers are kind of JavaScript-y, sort of. Cross-site scripting, just to remind you, is the only attack that is designed 100% only for JavaScript. That's all it does. Oh, and just so that you know, cross-site scripting, XSS, same thing. And just to define it one more time for you, because if you've never heard of this before, it's when your app confuses user input, so that's data, for instructions. It mistakes it and thinks it's code. Then your browser interprets that code as if it's part of your app, and it has all the same permissions that your app's code does, which means it can do basically anything that JavaScript is capable of doing. And you better believe it, that only your imagination is the limit. And cross-site scripting is a form of injection, and it sucks. It totally sucks. So again, because this is the most important part of the entire presentation, we do input validation. We sanitize or escape. You don't have to do both. So we take out the bad characters, that's sanitization, or escaping, we just add a backslash in front of a special character like a single quote, a special character like arrow brackets. And then we output in code, hopefully using a beautiful framework like Angular, Vue.js, React. And we use content security policy header, which is a security header that I think is amazing. Okay, so now on to number 4. We want to avoid inline scripting. So inline scripting, basically, as tempting as it can be to include your JavaScript directly with your HTML and kind of switch back and forth, which I remember doing back in the day when I was first learning. It makes it super easy to have cross-site scripting by accident. It is so much easier, like for long-term management, for readability, like just for version control. If you define your scripts in content security policy header and you have your scripts separate and you have your HTML separate. It's similar to inline SQL, where we combine user input and then feed it directly to the database. That's really insecure and we don't want to do that either. So instead of having it all woven in inside, we use quoted data variables such as like source equals. So like this, so source equals, something like that. But let's not do inline JavaScript because when we do that, it makes it so that content security policy header doesn't really work. It's not as good for performance, it's not as good for maintainability, and it's just not a best practice to do that anymore. So please don't do that. Number 5. I really like pictures of animals. That's why there's so many animals in this presentation. Like, I like to have a lot of graphics, and so I hope that you're appreciating. They get cuter and cuter, in case you're wondering. Okay, so we want to treat user input as something only that we would display or that we would save, but not something that we would use to make a decision on. And that's basically how injection and cross-site scripting happens, right? So if we treat it not like the stuff we get from the user, it's not used for logic. So we don't make a business decision with it. So if we all did this all the time, a lot of instances of cross-site scripting and other injections would all disappear. So if we apply this as a general rule or a guideline, then and we follow this whenever possible. So like if you don't follow it, there needs to be a business requirement and reason why not. And if we know, okay, so I do have to use this for business logic. I do have to make decisions based off this. We remember to proceed with extra caution because user input, we need to treat it like it's radioactive and dangerous. And so any user input that the user gave us could be malicious. And we need to also think anything that the user could have changed. So let's say you have a hidden field. That is something a user could change. If there's a URL parameter, that's something a user could change. And you need to treat that as user input still. And so you need to be very, very careful. Okay, so now let's get into like more code stuff. So let's start with number 6. So we would prefer to use text content or create element rather than using inner HTML or outer HTML. So inner and outer HTML are pretty dangerous because they dynamically render what you put in them. And so they often are the cause of cross-site scripting, which we don't like. And so if we could use text content or create element instead, then we don't have to worry about it, right? We just put our user input in there and we are fine. Inner HTML and outer HTML are dynamic and they interpret what you put in them. So we got to be safe with those. Ideally, we would use encode URI component and decode URI component instead of escape or unescape. So when we use encode or decode URI component, it breaks down each part of the URI. So you probably like look at an address in the URL thing and you're like, yeah, that's the address. But there's the schema, there's the port, there's the subdomain, there's the domain, there's fragments, there's so many different parts of it. And so it breaks down each part separately for analysis, and it is way safer. There are all sorts of different types of attacks that are done on URLs um, that focus basically on that, and some of them can bypass the escape and unescape functions. And so it's way safer if you use encode URI component, not just encode and decode URI. Component is the key part here. Okay, now on to number 8 with a cute little trick. So ideally, we would use create element or append child instead of document.write. So basically, this helps prevent DOM-based cross-site scripting. So DOM, the document object model, is where we'll store like a lot of state information and stuff like that when we're doing JavaScript. And that's cool. But if we accidentally store a cross-site scripting attack in there, it can be such a mess. Um, we don't want that. And so DOM-based cross-site scripting is the most complex one. And I know this isn't a lesson on cross-site scripting, but you can't talk about JavaScript and security and not constantly mention cross-site scripting. I'm sorry, it's the rule. So if we can avoid functions like inner HTML, this will help us avoid injection into the DOM. So basically, any sort of dynamic element can be dangerous. So these functions specifically create element and append child. They use the element properties, which are static instead of dynamic, so they're not interpreted, like text content, set attribute. These are way, way safer. Also, these functions offer very fine-grained control over the elements and the attributes and the event handling, and they work well with modern frameworks. Document.write is basically banned from the new frameworks because it's dangerous. Also, document.write could potentially overwrite your whole page and totally ruin your whole day if you do it wrong. And so document.write completely stinks. We should not use it anymore. That's it. Send tweet. Number 9, don't use unescape HTML. So ideally, we would use an alternative like the he library or Lodash instead of unescape HTML. It's not part of standard JavaScript, this function. So it's been around a long time, but it's not technically part of the standard JavaScript language. And it doesn't really decode things quite right, meaning it can allow some dangerous characters in by accident that can easily lead to cross-site scripting. So this specific function's been exploited lots of times by bad people. There are also many other cooler functions you could use instead. Also, this function can easily be confused with unescaped with a D at the end, which is deprecated and very, very bad. And we should never, ever use that one. And so please don't use unescaped or unescape HTML. Instead, we want to use he or Lodash. Those are way better. Okay, so remember we talked about using encode URI component and decode URI component? We want to use those instead of just encode or decode URI. So we pair these functions together. So decode URI component and encode. So we encode it first, then we decode it after, generally, unless someone passed something that was encoded and then we are in fact receiving and then decoding. But basically we pair them together. URI components are any part that lies between the separators. So you have HTTPS : / all of those things until the end are different components, or separators. And the separators, each one of those pieces are encoded because they're regarded, so then they're treated as text instead of special characters. The component, is capable of also decoding more characters, and this includes special characters that we might want to use later. By using this one that breaks up every single piece instead of trying to do it all as one unit, it prevents incorrect parsing, which can be dangerous for cross-site scripting, but also just make things crash. So we only use decode URI if we know 100% sure that it is a complete URI and that we're certain it's complete and that we validated it in other ways, which is more work, right? Why would we manually validate a whole bunch of things when we have this perfectly good function that does all what we want? So we should do that. Number 11, we want to make sure to URL encode data before we pass it to the CSS URI method. So we do this because it doesn't do it for us. So cascading style sheets are super cool. They make things very pretty and nice. That is awesome. But they are not really protective generally. That's not their job. Their job is to be beautiful. And so it doesn't actually encode anything for you. So you must make it safe before you give it to your CSS. It is expecting something that has already been encoded, and it treats it as a literal URL or file path. Like it's just like, okay, I'll go there. It does not check first. CSS isn't a programming language, and so we shouldn't be making it do a lot of work. It is weak. JavaScript is strong. We should do all of our work in the JavaScript language. Yes. Okay, now to number 12. So when we're in the execution context, and by that I mean we're hanging out in the DOM, we would URL encode, and then we JavaScript encode, because contextually we're in a sub-context, because we're in JavaScript and URL. I know, you got to do it twice. And yeah, I know, it totally sucks. If you are going to put something that is user supplied or something that could have been changed by the user as data into the DOM, we have to do it twice. Like if we're putting it into our URL attribute. And so like this is complicated, I know. If you are mixing your JavaScript with your HTML, you also have to do sub-contextual, and by that I mean nested encoding. And it's hard. And that's why you just shouldn't do it, right? Like ideally, you would never put anything into the DOM that's from the user, but sometimes we have to, I know. But if you can avoid it as much as possible, that's great. And then only do it when you really need to. Okay, so now we would like to take superpowers away between the script tags. So if we are in the execution context, so this means the DOM or between the script tags, we set our string or text content using the text content assignment property, right? So if we want to set text or like a string content, we use the text content assignment property, right? So for example, we would do your element.text content equals whatever the text is from the user. When we do this, we've taken away any superpowers. It does all of the encoding, escaping, all of that for us. So it is just treated as data and cannot be mistaken for code. And again, this is just another of the 400 different protections against cross-site scripting. I know you're just like, wow, this is a lot. Yeah. A lot of us that work in software security, we just really would like to say goodbye to cross-site scripting. That is the thing we would like to do. We want to specify that text is text. So this is number 14. If we can say that text is text if we're putting something from the user into a data element for JavaScript or CSS cascading style sheets. So for example, do not use inner HTML. Instead, we would use inner text or text content. So yeah. So if we say inner text or text content, what we're saying is this is text. Please treat it as such. This is definitely not part of your code. We don't want the DOM to guess and decide for us, because when it does, it gets it wrong sometimes. And then we have cross-site scripting, and then we're unhappy software developers and security folks. Basically, all of IT has a bad day. We don't want this. And unfortunately, often our customers have a much worse day. And so we don't ever want to leave things ambiguous when it comes to security. Well, when it comes to computers, basically, ambiguity is the beginning of falling into an unknown state. And when the computer does not know what instruction is next, ugh, it's bad. Usually crashes, but sometimes worse things. Number 15. So when we set element.set attribute, we should use safe and static attributes. And this is a huge long list of yes. So all of these are static. They cannot be changed. They are not dynamic and interpretable. All of these are safe. Put your stuff in there. Please do not, ideally, take user input and put it into on click or on blur. Those are dynamic. So anything where like the mouse moves and you're detecting it, no user input in there, because that's dynamic. And so then it's interpreted. And so please don't put anything from the user in there. Yeah, big red X of no. Mm-hmm. Okay, so more unsafe dynamic attributes that we would like to avoid. So event handlers. So on click, on change, on mouse over, on load, on error, anything that starts with the word on. Don't put code in there, please. Please don't put code in there. On top of this, we want to check, so form controlled values that are, so like valued, checked, selected, disabled, read only. Those again are dynamic. You might not think of them as dynamic, but they are. Href, source, action, form, Boolean flags that could be untrue. So a Boolean attribute is there, like, then they're considered, so if it's there, it's considered true, even if you mark it as false. And I know that that sounds weird, but like, oh, if the Boolean flag is marked to false, it's like, oh, I see it. It's there. Oh, it's true. I know that sounds dumb, but basically even Boolean flags could be a problem. So you need to be careful when setting these attributes with anything to do with user input. And if you're setting it like dynamically as your code is running, then chances are you're putting user input in there. And so please think twice before putting user input into any of these. Okay, so number 16, if we're making bad choices, and by that I mean we're doing inline JavaScript, which we've already agreed we're not going to do anymore, right? We've agreed to this. If we are using JSON, we should verify that the content type header is set to application JSON and not text.innerHTML, which can basically, so if we let it guess, sometimes it guesses wrong. So if we're using JSON, tell it we're using JSON. So it doesn't think we're using text and HTML because it's like, oh, this is HTML. Maybe I should interpret it. No, right? So first of all, let's just not use inline JavaScript. That would be the best choice. But if for some reason you have to, like you're working on an app that's like 5 million years old, it's from, they found it in an archaeological dig. And for some reason they won't rewrite it, and it is written with inline JavaScript, then please be careful and set your content type headers accordingly. Number 17, variables, and by that I mean user data that go into CSS property. They go into CSS property values, not into CSS contexts, because contexts are dynamic and values are static, and we only want to put user supplied data into static things. So for instance, style, selector, property, see how we're saying the property, value. Yeah, that's right. And so property equals whatever is done, and then we just slash out and we're done. So again, we want to put stuff into this like user supplied information or information that could have been changed by the user because it was in a URL parameter or a hidden place or something like that. All of those things go into static values or properties. They never go into something that can be dynamically interpreted. I find this one particularly cute. It sort of looks like it has three heads, but it's actually just three penguins. But there's no trench coat, right? So when we're using JavaScript, we should turn on strict mode. That's the whole message. JavaScript should be executed in strict mode only. Same with TypeScript, which has a strict mode. If there's any language and it has a strict mode, that's what you should be using. Why? So it enforces stricter parsing and error handling. It prevents accidental global variables. It blocks the this function, which is, we don't want to use that, from binding to a global object, again, preventing global scope that is accidental. It prevents us from deleting undeletable properties for objects, which helps prevent attackers from trying to mess with our objects, which is a whole thing that we're going to talk about in the next slide. There's a whole bunch of reasons that we should use strict mode, and please use it. If you see a JavaScript app and it doesn't have it on, ask why, because you should have it. We want to avoid HTTP parameter pollution. So ideally, to do this, we would use the HPP module with Express or HPP middleware, which can be used with React and Angular until they get their own module for that. But basically, the vulnerability, the way that HTTP parameter pollution, or HPP as it's called, which is a bit of a tongue twister, it's where an attacker sends extra parameters, but with the same name. So for rec.body or rec.query, it sends extra parameters with those names, except for obviously the values they're sending are an attack, right? So you can write code manually to defend against this. So you could do input validation on the server side with an allow list and do sanitization or escaping, and you can configure your framework around it. But if you could use the middleware, or if you're using Express, use their module, that would be better than writing it yourself. I have had clients where they've asked for a lesson only on this because they've been attacked so many times. This is really, really malicious. I recommend highly using the DOM Purify library. It protects against DOM-based cross-site scripting. The person that maintains this is a superhero. Like really, they do such a good job. Whenever people file issues, they fix them. Like this person's very active. Thank you to Cure53 for doing this and making it free. That's amazing. This is a very, very good library, and I would like to recommend it to you. Use sub-resource integrity, so SRI checks. It verifies the integrity of any external scripts you use. So when we're loading external resources, including scripts, obviously we would use content security policy header as well, but we can securely load them by using SRI. So it's a check when we include them in our code. Even if it's from a content delivery network, a CDN, we still verify that what we're getting is safe because that CDN could have been attacked, right? And so sub-resource integrity checking is a feature built into modern web browsers that uses a cryptographic hash to verify the integrity of this internal script. Lack of verifying integrity of things is on the OWASP top 10 risks to web apps because guess what? It's a big deal. We need to validate the integrity of things because malicious actors have figured out that they can switch things out and that a lot of us weren't checking. And so we want to check whenever possible. Number 22, we want to minify and bundle and nonce. So basically, if we can minify and bundle our code, it makes it harder for malicious actors to read it. And then we can add a nonce, which is just like a bunch of random characters. And basically, when it goes to unlock it, you have to present the nonce and they have to match. If it doesn't match, it's like, no, sir, nope. You can use something like Webpack to do this for you. And this is an extra additional layer of security. So this is not mandatory, but is a thing that would be nice if you did. We also want to avoid cross-site request forgery. So if we are going to perform transactions in our JavaScript, so transaction would be like a purchase, or for instance, let's say you're playing games and you're doing a currency, like an in-app currency purchase of something, that's still a transaction. Let's say you're trading something with someone and you're like, I'll give you this sword for your grenade in this game. That's a transaction, right? Like when you delete an account, that's a transaction. Like there's so many things that are a transaction. And whenever you do a transaction, you need to pass a token. And so otherwise, if you were already logged in and you click a malicious link by accident, which happens to all of us sometimes, CSRF, cross-site request forgery, is where basically like you click this link, you're already logged in, and it tries to initiate a transaction in your logged in account, but it is not a transaction that is in your best interest, trust me. And so we pass a token from the front end to the back end, back and forth, because that token won't be part of a malicious link, right? It doesn't know to pass that token. And so this means you need to check on the back end that you've received the token, because if you don't check that you received it, there's no protection. And so this can be a hidden field. It doesn't need to be super well hidden to work as a defense when you pass this token. This protects against phishing attacks when a user clicks a link that tries to initiate some sort of transaction. Even if a user's logged in, if they click a malicious link, it would not contain an anti-CSRF token, and thus it stops the attack in its tracks. If you're using a JavaScript framework that does the front end of CSRF, that's awesome. You still need to code it to check at the back end. Please use a static analysis tool, a SAST. So static analysis tools are like SemGrep, Checkmark, Sneaks, Fortify, like there's piles and piles of them all over the internet. And I'm going to give you a list at the end of the free ones, but also use a linter on top of that, like SonarQube, right? So we want to static analysis and lint. So linting is like code quality, making sure you're strictly following the language. But static analysis looks for vulnerabilities specifically, and they overlap quite a bit, but not 100%. The Venn diagram's like this, not like this. So we want to make sure we use both tools, and then we should fix things that we found. Yes. Okay, so now I want to switch gears slightly to dangerous functions, things that we want to avoid, because here be dragons. Okay, so you might want to take a screenshot. Here are some functions I'd really like you to avoid. Eval in every language, please. Do not put user input in there. Oh, please don't. Inner HTML, outer HTML. The functions function. I know. Escape, unescape, document.write, unescape HTML, unescaped with a D, which has been deprecated a long time ago. But in case you are doing an archaeological dig in your code, decode URI and encode URI. If we could just avoid all of those regularly. And if you have a stack analysis tool where you can write your own rules, probably it has rules for these, but if it doesn't, you can add them yourself. Avoid using the with statement. The JavaScript with statement is like pretty bad news. It allows for simplified access to object properties by establishing a default object scope. That sounds nice, right? No. So although it's reduces like scope repetition, right? So you're like, oh, my coding's faster. It's generally discouraged / kind of outlawed because it confuses so many things and it has negative code on like negative impacts on code maintainability. And negative impacts on performance. And it's really important our JavaScript goes fast. The with statement also specifically, the reason from a security perspective not to use it is it violates something called lexical scope. And what that means is it makes static analysis completely impossible. It breaks SAST tools. So if you have strict mode turned on, it'll be like, no, no, with statements not allowed, right? So I've already prepared you to not use this, but please don't use it. We want to avoid function constructors that have a string parameter. If we're like you can set it with a string you choose, but it can never be user input, right? So like if we could avoid them all the time, that would be great. But basically, like I've had people say like, oh, well, what if I'm using a function constructor that has a string argument, but I'm not putting, but of course you're going to put a variable in there. That's why you're doing it, right? So please don't put user input in there. 28, be careful with set timeout and set interval. Um, like, especially if you're going to put user input in there, consider putting it in a different function instead of those functions. Like ideally, we would never put user input into them, but like if you need to use user input, use something else. There's like lots of different other functions that can do these things. I should probably add those to this presentation, but basically, please don't use user input with either of these. 29. Avoid JavaScript methods that take code as string types. So before I talked about functions, and now I'm talking about methods, which are slightly different. So what do I mean? Set attribute, set timeout, set interval, the new function. Instead, we want to set the attribute directly, right? So we're taking a string. We never want it to be interpreted because we don't want JavaScript attacks like cross-site scripting. Okay, number 30, dun, dun, dun. Oh, look at this beautiful cat. Do not put untrusted data into HTML rendering methods, right? Just like the last one, we want to set the attribute, right? So what would be HTML methods that render themselves? Inner HTML, outer HTML, document.write, document.write line. These are all things that render what you put inside. We never want to render something from the user. Okay, one more. We want to, I know, another. So we want to avoid prototype injection. So Java is a prototype-based language. We need to avoid injection into our prototypes. I know, another type of injection. This sucks so bad. This is an attack where an attacker manipulates or overwrites properties in a global object's prototype. For instance, because JavaScript uses prototypes for inheritance. So they overwrite the first object and then everything else inherits the badness, right? That's obviously awful. So if an object doesn't have a proper property directly on it, the JavaScript looks up the prototype chain up the line of inheritance to find it. If an attacker manages to change the original prototype, all objects that inherit from it are affected. This is like it. So does this happen every single day? No. Does this happen sometimes and then it's the end of the world? Yes. So one, freeze default objects that everything else inherits from using object.freeze. Explicitly create objects that do not use prototyping. So create object.create and then null. Use map instead of object. We could do that. Or we could just avoid recursive merge functions altogether. Like don't do all this inheritance stuff, right? Just don't do it. Okay, we are so close. Don't mess with the same origin policy, right? The same origin policy prevents one website from accessing data or resources from another unless they're intentionally shared. We do not set the same value for document.domain in order to share information between two pages because this ruins all the protections that it gave you. Instead, oh, I just said this. Instead, so we don't want to set window.postMessage to star. Instead, we want to use window.postMessage, right? So like we put the thing in there that we want. And so we should check the origin and validate whatever is in the message before we use it. So we send it in a message. We don't put a star. And then what we receive, we still are suspicious and we validate it. Yes. Um, 32. True validation happens on the back end. So JavaScript, we love it, but we can't trust it. It needs to be done on the back end. The like front end validation, we can do that to save time so that it's like instantaneous and it looks really good. But anyone with a copy of Zap or Burp Suite can easily get behind the JavaScript in 2 seconds and then send things directly to your back end. So the final decision is made on the back end, and I'm quite serious about this. That's why I chose like little spiky thorns for this one. We would prefer private variables over global variables because they are less likely to be accessed by external scripts. And this goes for every language, not just JavaScript, but I want to remind you because I want you to write beautiful JavaScript. And now I'm going to give you some free JavaScript tools, a couple other resources, and then we're going to do Q&A. So free JavaScript tools. So these are free for everyone. Their licenses aren't like a shareware or where you can only use it so many times. These are free forever types of things. So there's SemGrep Community Edition, which is free forever, not just for 10 users like their pro version. DOM Purify, this is a library. It's absolutely free and you should use it. Retire.js can tell you about JavaScript libraries that are old and vulnerable that you should not be using anymore. NPM Audit, especially if you are doing Node.js. Yarn Audit, again, these will check your all your dependencies and see if they're out of date or potentially dangerous. Horosec, so that is another stack analysis tool like SemGrep Community. Node.js Scan. Bearer. Bearer will check your dependencies, but will also do privacy checks, which is pretty cool. DOM Snitch, which will look for DOM-based cross-site scripting. I know the name's a bit much, but it's helpful. Okay, so I have a conclusion. So we learned a whole bunch of insecure functions. We learned better alternatives, so safer functions. We talked a lot about how to avoid cross-site scripting. We talked about free tools and how secure code really matters. And so now some free resources for you. So the first is a free academy I built called SemGrep Academy. Now you pay by giving your email and they add you to the marketing newsletter, but if you need to, you can unsubscribe. There is a secure code course in there for free that I built. Everything in there is free. So if you want to learn more from me, you could start there. Books. The books are not free. I'm sorry. That's how the world works. But I feel like they're reasonably priced. That URL code is a list of all the different countries and places where you can get them. So if you don't live in the United States, there are still many, many options for you. I have a petition. If you are a Canadian and you are watching, please consider signing. I am petitioning the Canadian government to adopt my secure coding policy as a federal policy, because as far as I know, they don't have one, and that sucks. Next, I have a free newsletter every month where I give piles and piles of free content and I invite you to events like this. And with that, I would like to thank you so much for your time and attention today. I really, really appreciate Black Hills and Anti-Siphon having me at this event. Yes.
Well, Tanya, we thank you for joining us today. We thank you for giving us such great information and opportunity to learn about the dangers of how we like to code things. And I know I was listening to you talk about the eval statement, and I remember I was always told eval equals evil. Do not do this. It's like, well, why is
That's
it
actually
there? It's like,
perfect.
yeah, like you just don't do that, especially when you get user input and you run it. That's a no-no. So very cool stuff. Very much enjoyed this. But now it is time. We have a few minutes left over, and if we like, we can do some Q&A. We can ask questions from the audience. We actually have a couple of questions that have already shown up in the Zoom Q&A. So what I'll do is I'll read them, or if you see one that looks really interesting in Discord or in Zoom, make sure to just say, hey, I got one right here, and we'll go through them. I saw one that looked really interesting. It was, are there cheat sheets available for download for all of these points?
So I was hoping to make one and I ran out of time. I'm sorry. However, if you join the newsletter, every time I make a new cheat sheet, I give it to the people on the newsletter because you have to sign up for my newsletter to get the cheat sheet. So I always just give it to them. So I've already given them um, several cheat sheets, like a security header cheat sheet, a cookie cheat sheet, a secure SDLC cheat sheet. I gave them the secure coding policy this month. So basically, I include those all the time, but I don't have one for this. So how about this? If you join now before the next newsletter, which I think is August 14th, um, I will commit now to having the JavaScript cheat sheet in there.
Look at that.
So
Ask and ye shall
compromise.
receive. That's right. All right. Another question that came in the Zoom Q&A. What SAST, DAST, SCA tools would you recommend to detect these vulnerabilities?
Okay, so only a stack analysis tool can check for these. And I work at SemGraph, so I'm biased and I recommend their tool. But I also can work anywhere I want. And I chose them on purpose because their tool is actually really good. There are lots of stack analysis tools on the market that can help you, but I find theirs is really good. Also, if you can't afford a free tool, a paid tool, they have a free one, and quite frankly, their free one is like hands down the best free one by like a landslide. And you can write rules for it, but to be quite blunt, I just make the AI write the rules. I know I work there and I should know how to write them, but I totally suck at writing them still after 2 years. And so just make the AI write them, and that's okay.
Yeah, that's
Um,
totally fine.
For DAST, I really like Zap, which used to be part of OWASP. They're not anymore, but it's really good and it's free. But if you have like a little budget, I really like Burp Suite. Burp Suite's so amazing. It has this giant community that writes all these amazing different plugins that do 1,000 things. And so if you have $500, which I realize is a lot for some of us, they have a paid version that's really quite nifty.
Yes, and Kaido is starting to make quite the splash in that area as well. So
Which
I
one?
would it's called Kaido, Caido.
I need to check it out.
I would definitely look into that as well. Another really good option for people that are doing web app assessments. So very cool stuff. Okay, this comes from Sophia Engvall, asks, does obfuscation really work? So easy to reverse.
Yeah, so I would say obfuscation will slow down an attacker by a bit. I have been attacked where they obfuscated their code, and I remember being in. So this is how I joined an incident response team. I asked if I could tag along, and then I was sitting there like watching everyone do the thing, and then they brought up the SQL server logs and they're obfuscated. And literally, it was just URL encoded. It wasn't even base64. They just double URL encoded it. And like I looked, I'm like, oh, %20, that's a space. Oh, that's this, that's that. And then I'm like sitting there and I'm like, oh no, it's SQL injection. Oh no. And so like I could decode that very quickly. And I've been in workshops, like reverse engineer workshops, where like it's a cipher and you can just decode it, but it takes time. And it can turn the reaction from seconds or minutes or hours to like days or weeks or months, right? And so and it's like, if you're, how do I word this nicely? If it's more difficult to attack you than someone else, 99% of the time, the attacker will go bother someone else unless you have a nation state attacking you. Like I would still do this, especially if I have nation states targeting me, but it just makes you more annoying and more work, and people will give up. And that's what we want. Not that we want them to go attack someone else, we want them to give up. And so it just slows them down. So it is one of many layers of defense. It is never like a full defense on its own.
I like that. It's like, yeah, I don't want them to attack anybody else, but I surely don't want them to attack me. So I'm going to start there. I'm going to put my mask on before helping others, right? As they tell you on the plane, right?
Oh, I see one from Erin that's in Victoria. If you are in Victoria in November, I'm speaking at the OWASP chapter in person if you want to come hang out.
Very cool. Sophia's got another question. She asks, how common is stored XSS in real life?
Hmm. Hmm. I would say, so on pen tests, I've found it like a bunch of times, But how many incidents have I've never responded to an incident where the stored cross-site scripting was the attack. I've only had reflected and DOM where I've had to respond live. But I mean, my full-time job was AppSec and I would just get dragged into AppSec incidents. So I don't know. I don't know how common it is. I have not had to personally ever respond to that, even though I've found it in pen tests a bunch of times, like an unfortunate number. So I don't know the answer to that, but maybe when we do the next top 10, we should include that, like for each of, because I assume cross-site scripting, unfortunately, is still probably going to be on there. I don't know yet. I haven't seen the data, but we're starting analysis next month. So I guess I'll see.
That should be an interesting analysis indeed. Samantha Lowrymore, who has an awesome name, asks, as we enter a quantum world, where do you see JavaScript security heading?
So I don't think that quantum will affect JavaScript. I think it will affect, well, I mean, like it'll affect a lot of things. Things will go faster and it's exciting, but I feel like it'll affect encryption more than specific programming languages, or it will affect us like in big ways that affect every language, if that makes sense. I am quite concerned about how malicious actors have been saving encrypted files for a long time, knowing that they'll be able to decrypt them soon. I, yeah, I'm not a quantum expert. I am hoping that the quantum experts, I have a friend that works closely on that for Canada and is like doing all this research and blah, blah, blah. And they're working on quantum resistant encryption algorithms right now, but I feel like where they're going with that, I don't know. Like they're working on it. I hope they're going to do it, but I don't know the answer, to be honest.
It's a brave new frontier, kids. So
True.
that'll be interesting. More to come as we learn more. This question comes from MJ. Can you share a roadmap to becoming a JavaScript guru? So like the elevator pitch for getting into JavaScript and being awesome at it.
So I learned JavaScript on the job. So I took computer science in college in the 90s. And then I remember applying for a job and they asked for JavaScript. And I was like, I already know like 13 languages. What's one more? So I just said I knew it. And I'm a weirdo where I can just program in most languages, even if I don't know it yet. Like when I did my interview at SemGrep, it was in Python and I'd never coded in Python. And I did the coding interview successfully and include recursion and matrices math. And I was like, matrices math. Anyway, it made me feel old. Daniel, it made me feel old. Um, I would say if you could do a boot camp and learn about that, and then perhaps take the free secure coding course in the SemGrep Academy, that could help, and or go through like the things from this presentation. I think that that would help. Um, I feel like, how do I word this? I feel like starting with how to code in general and then going over the secure and insecure functions. It's my hope that a JavaScript bootcamp would teach some of what I said. So they'll tell you to use strict mode. They'll tell you not to use the with statement. Those are general best practices. But for the rest of it, I'm not 100% sure exactly what would be included in a boot camp versus, and it's the same if you go to university or college. Like I'm just going to tell you quite bluntly, they also don't cover secure coding. I have not met a single university or college yet that covers it. I have met one person from one university ever that has an application security course. The rest of them just have basic web app hacking with the OWASP top 10. And that's still quite rare. And so no matter where you go to school, unless you like go to school with me or someone like Jim Manico or like a specific secure coding feature, you won't get that. And unfortunately, all of us, what we do is we teach people who already know how to code, how to do it securely. You know, I wonder if there's a market for teach me secure coding from the beginning, like where you teach them how to code and you include it as security from the start. Do you think people would like that?
I would think so, especially because we've become such more security minded in general. I think that maybe because it does take, there's a bit of an accordion effect in my experience when it comes to universities, colleges, where they play catch up a lot. They're the last to kind of incorporate and have a mature program for teaching you X, Y, or Z concepts or skills. So maybe they're just going to come along in a little while, because it does seem a little odd that there would not be more, especially if you're taking a cybersecurity degree program that, hey, we're not going to teach you a little bit of coding. We're going to also teach you secure coding. And if you just bake the two things together, I kind of get why they might separate it, but you're already there.
When I wrote my first book, the Purple Book, Alice and Bob Learn Application Security, I built it so that they would do it at universities, so that they would teach it. And all of them refused, basically, like that I reached out to. All of them were like, yeah, you can be an adjunct professor. We will pay you minimum wage, like less than minimum wage. And then we own all your intellectual property. And I was like, that's literally the crappiest deal ever. No. And so now I've written Alice and Bob Learn Secure Coding. And basically what my plan is to teach it on the internet. So with my first book, I did free lessons on every chapter, and I'm going to do that again with the new book. I'm also going to build like a bunch of courses online as well, so that it can be like a bit, I don't know, I'm working with Anti-Siphon, I'm working with OWASP to try to have live classes, but not everyone can attend those or afford those. So I'm working on other solutions. But yeah, it takes time, but I'm working on it.
Well, we appreciate your effort. That is for sure. Thank you
Thank
so
you.
much on that. More questions coming though, and this is a really good one. I like this question. Have you seen an effect of AI vibe coding versus security personally?
Okay, so, okay. Now that my laughing is done. I'm like, laugh quietly. Okay, so when I make training, I will use, so I've discovered that, so what I do is I do bad, better, best. So I'm like, this is bad code. And it will just not include any of the security measures I've discussed. And then better code. So I add whatever the most recent lesson was that we did, then best code. And then I add multiple layers of defenses. And I've discovered if I ask the AI, it naturally just does the bad code. I've only once had to remove a security thing to make it bad. All the other examples were just bad to start. And yeah, I don't know what else to say. So yes, I've absolutely noticed that. I've also noticed that everyone's producing code way faster, so fast that the security professionals who were already struggling to keep up now can't keep up at all. And it's like, you still have to do security checks. Like, you still have to do a review. You still need to do all these things. And they're like, oh, it's been 5 minutes. My code's ready, because Claude wrote all of it. And then we're sitting there and we're like, but before this took 6 months, right? And now it took one day. And now you still expect me to do all of my job that I would usually have 6 months to do right now. And so we are working on solutions. Hmm.
Yeah, I saw last night, I think I read an article about Base 44, which is a vibe coding platform that has vibe coded elements to it, had security issues. That if you're going to vibe code things, from what my understanding is that you need to give it context that I need this to be securely done, because otherwise it just goes, oh, you just want the thing. Here's the thing. It will work. And you're like, yes, it does. But you put all these eval statements in there, and dang it, you like just start your prompt with eval equals evil. Do not do that. So you have to tell your vibe coded app that you need security. You need to be thinking securely. If this, I wanted to make sure that you have to go back and tell it, is there any cross-site scripting vulnerabilities? Are there any, HPP vulnerabilities? Are there any of these types of vulnerabilities? Look at the OWASP top 10, measure it against that. It will do all that stuff. But if you don't tell it to do that, it just goes, cool, here you go.
Yeah.
Oh, we got a nice question here from Tai Quan Gong.
Hmm.
I understand the data types of coding, but I have a gap in creating a program or app. What do you bridge this gap with? Like, how do you bridge that gap? How do you go from I understand programming to now I can make apps?
Hmm. So I find that kind of hard because I studied computer science for 4 years in school. And I guess that they taught me that as I worked my way through. I also worked at a software boutique writing code. Mm, so I guess I learned to code in high school and I took a class. And basically, I remember my teacher. So he didn't know what to do with me. So I come from like a line of software developers. Like all my aunts and most of my uncles are software developers. My mom's a mathematician chemist, right? So when I learned to code, it just like, some people can pick up an instrument and just play. I like could just code. I just got it. I don't know why I just got it like immediately. And so I took 3 years of computer science in high school, and my teacher did not know what to do with me. And so he was like, "Oh, what app do you want to write?" And I'm like, "I play guitar, so I'm going to write a how to play guitar app." He's like, "Great." And then he's like, you know, "We give math tests to lots of different students. Like, should I like?" He's like, "Could you like create like an automated math test that marked itself?" So I made it so every single math student in the school got a different test, so no one could cheat. And like I didn't understand at that point, like, oh, this is something I'm very good at, right? Like it took me a while to get it. Like I remember my first year of computer science at one point, like the programming teacher was like, "Well, if you know so much, get up here and teach the rest of the recursion lesson." So I just got up and taught the class. Like I didn't, I have ADHD and dyslexia, so I don't always get social cues. I was like, he said I could just get up and teach the class. Everyone's like, "I can't believe you effing did that. You just got up and taught the lesson. What's wrong with you?" I'm like, "He said I could." And like I did. And eventually he just laughed. And I just taught recursion to everyone. I was like, "Here's what we do." And I drew pictures and I got everyone doing recursion. And so I feel like I just did it and I didn't understand that like that wasn't a thing. So a thing that can be hard is if you're a natural at something, how to understand how to explain it to others when it just makes sense to you. So like when I learned music, it was really hard. I was not a natural. It took me 2 years to be able to play like a decent song on guitar. And so I'm good at teaching guitar because I sucked at it so bad. But when I learned like hacking and stuff, like that took quite an effort from me. And when I had to switch from coding to secure coding, that took a lot of effort. But for some reason, like I just made software. And so I'm sorry that that's not helpful. However, I have a suggestion. If I were you, I would join an open source project. There are so many open source projects, especially with OWASP. Looking, and I know I'm biased because I'm part of their community and I love them, but there's so many open source projects that are looking for volunteers to help. And then you'll learn about how they make code and their processes. And then eventually you'll be like, "I know how to make software," if that makes sense. When I wanted to learn DevSecOps, I started an open source project with my friend Nikki, which is called the OWASP DevSlop project. And like we made CI/CDs and then we added security tools and then we figured out they were too slow and everyone was angry with us. And then we learned how to go faster. We learned how to pen test in a DevOps environment. And like that thing made us um, the security professionals we are today. And so I highly recommend doing, it sounds weird, but doing some volunteer work.
Yeah, I think that's a great way to fly. And if you're super brand new, I've seen a couple of questions coming in about people that are like, I am I'm new, like newborn baby new at any kind of coding projects, right? Just find projects. I did a whole YouTube series on learning Python because I was like, I want to give back to people that are just getting started out and they want to cut their teeth on stuff, learn some programming basics. And because I normally just use Python for a lot of things, that's what I went with. And it was like, you know what I'm not going to do? I'm not going to go, this is a variable. A variable is something that holds information. No. Now you understand variables. It's like, no, let's build something. So I built a brute force app that brute force passed the web authentication. And everything we do, everything we learn is wrapped with around the context of building that application. And it incorporates a ton of some of the basic stuff. So I think those are some of the best ways to go. Just find a simple project and then go, okay, I need to learn those basics. I need to learn those fundamentals of why do I need a variable? What are different data types? What is a loop used for? Why do I need loops? What purpose do they serve? And
They're the
how
best.
to Yeah, they're great, right? You talked about recursion. I love recursion, right? It just makes this, I like making little menu driven apps. So it's like, oh, make an app that makes you ask X, Y, or Z. You choose X, it goes to that, it does the thing, and it comes back and goes, okay, I did the X thing, here it is. Now you can choose X, Y, or Z again. Which one would you like? And you just keep recursing your way around the the app, and you're like, until you go, I'm done. X, be done. So I think those are the best things to do. Go find yourself a good little project, something that is means something to you, that's interesting, and then attempt to learn, take those things you're learning and apply it to that.
Hmm. Someone
Questions?
asked if I'm going to share my slides. Is there a way for me to give you guys my slides and then you share them?
I
Like
believe
how?
there is. We have had other people share their slides. So if you want to get with Ryan or Kurt or Megan after this
Yeah.
and get that over to them, they can get that. And I'm sure that we can get that shared out because I'm pretty sure we have shared slides in the past.
The slides are in the resources in Zoom, and they are also in Discord under the slides and resources.
Well, how about that? Beat us to the punch. Thank you, Megan.
Also, people were asking about how they can sign up for the newsletter, and it's newsletter.shehackspurple.ca because I'm Canadian. And so also I just put like the little QR code. Oh, but I'm sharing my screen, but we can't see it, but that's okay. But it's newsletter.shehackspurple.ca.
I just put it in the Discord chat.
Oh, that's where I should have put it.
No problem. No problem. We're a team here. That's right. We work as a group, man. We got it all covered. We got Megan telling us where the slides are. I'm throwing in your link in the chat. It's easy peasy. We like to make it that way, right? Have a lot of fun.
Mhm.
All right. Let's see here. Any other questions? If not, we are kind of running up on about 20 over. So if there's no more questions, we'll look and see. I don't think we've missed anything. Yeah, I think we've gotten them all. Unless there's any more questions, then I guess we'll call it a day. Tanya, thank you so much for this enjoyable, wonderful, fun, exciting. You're such a fun person, right?
So are
Your
you.
smile and your energy is infectious. I love hanging out with you. So thank you so much for hanging out with us today. And we look forward to utilizing these resources which you dropped on us today. I'm definitely going to check them out as well. So thanks everyone for watching. We hope to see you next time. And until then, have a great day.